Go live. So yeah, like I said, welcome back. Day 1.5. Unfortunately, earlier my stream was cut short due to my mother walking in, which is totally fine, by the way, but I did have to end the stream. So yeah, we're back for day 1.5 because I was on here earlier and we're back. So, first things first, I'm actually gonna, I guess, put this, I'm gonna keep that like this. And then I'm just gonna open a terminal and then W? Nope. Control Alt T, Control Shift O. Cool. So now we got this back up. If I remember correctly, it's CD documents and then CD documents. Unfortunately, actually, let's move code block or CV projects to just projects, and then that's okay. CD dot. Okay. So now that we've got this little environment set up, this is gonna be the nano. So we're gonna nano hello world here, CD projects. Wait, let me clear nano. Okay, and up here, let's kind of go clear, even though it was already clear. I don't know why I did that. So yeah, we're back, and it says the best practice here is to comment my code liberally. And write your comments as if speaking to someone who has no idea what the code does. Don't assume you'll remember why you made specific choices, which, as I said earlier, is important. Commenting out code. Converting one or more lines of code into a comment is something called commenting out code. So obviously we can do that by adding 2 slashes right here. Bam. So now if we run this, let's actually do it up here. G++, hello world, and then A. As you see, nothing happens because it's just returning 0, or not even. It's just ending, right? So, as it's saying here, we can do it multiple ways. We can comment out each line individually, or we can comment out the whole stack. Let's just run through this again. Instead of doing that, we can go like this, right? And then we can go down here and then comment this out like that, right? You can save this. Let's try running it. Actually, let's do ls. Okay, it's still always going to be a out. Yeah, as you can see, nothing happens because we commented out all the lines of code. So let's go back down. Delete this here. Also, I want to see if this is tabbed. Okay, it is tabbed. I wonder, is there any problems with C++ and like spacing or something? Like, I know Python has problems with that. So let's try something like this. Oh, no. Okay. So let's try executing code again. And then A out. Okay, so it still works the same, which is surprising. No, the delete key isn't working. I mean, I presume it was working. I just had a weird amount of spaces. So let's write hello world. Clear. Cool. So now we know about commenting. So there's a few reasons you might want to do this, as we read above. So the reasons you're going to want to do this actually is you're working on a new piece of code that won't compile yet, and you need to run the program. The compiler won't let you, and there are errors. So obviously you can save parts of your project without deleting it, I presume. You've written new code. Yeah, okay. For code block. Okay, so we aren't even using either of these because I guess this just works, right? In lesson 1.1, statements and the structure of the program, you learned that the majority of instructions in a program are statements, and the statements are grouped into functions. So let's go back here. Let's review. Statements are, what do they do? Statements tell, like, the code what to do, right? Causes the program to perform some sort of action. Whereas functions are a collection of statements that execute sequentially So statements are something that executes instantly, I guess. Instruction that causes the program to perform some sort of action, and obviously functions are multiple statements. Oh, I didn't know you could do that. Well, interesting. Let's see. So let's go back over here to 1.3. Key insight. Programs are collections of instructions that manipulate data to produce the desired result. Program can acquire data in many ways, from a file or database over a network, from the user providing input on a keyboard, or from the programmer putting data directly into the source of the program itself. The program Hello World. Let's go back over here. This is our program. The text Hello World was inserted directly into the source of the program, providing data for the program to use. The program then manipulates this data by sending it to the monitor to be displayed. Data on computers is typically stored in a format that is efficient for storage and processing, and is thus not human readable. Thus, okay, so it said it's stored, right? Let's read this. Data on a computer is typically stored in a format that is efficient for storage or processing, and is thus not human readable. So I presume what it means by that, obviously, if we cat A, this isn't human readable. This is stored in the format that is efficient for storage and processing. Cool. Okay. Thus, when the program, or when the Hello Program World is compiled, the text Hello World is converted into a more efficient format for the program to use, binary, which we'll discuss in a future lesson. Objects and variables. All computers have memory, called RAM, short for random access memory, that is available for your programs to use. You can think of RAM as a series of mailboxes that can be used to hold data while the program is running. A single piece of data stored in memory somewhere is called a value. In some older programming languages like Apple Basic, you could directly access these mailboxes, also known as you could directly access the RAM, I presume. A statement could say something like, go get the value stored in mailbox number 7532. In C++, direct memory access is not allowed. Instead, we access memory indirectly through an object. Okay, so it's actually, let's get a little touch, like, what are we? Actually, we can just nano it. Okay, so there are multiple things we need to save here. Let's go back up into structure of a program. Okay, so these are my notes. Let's add a little Austin's notes. Is my internet still up? What are we adding? What does the plus plus mean? Nice job. Well, if I think back, C is the more basic version of C++. So, I may be incorrect there, though, but... Are you... Okay, well, it appears... Okay, so obviously we can... okay. Okay, so what does the plus mean? What are we adding? Yeah, that's a good question, Mr. Walrus Productions, also known as Redcon. And unfortunately, I don't have the answer for you at the moment. Actually, you know what? I know you're probably not even watching right now, but we're going to go grab that answer. What does the plus plus mean in C? No! That's not what I meant. C versus C++. Okay. Why is it called? Actually, you know what? I think that was mentioned in the even earlier lesson. Let's see. Manual allows for better management of memory. Garbage collection. Interesting. So, let's run back up here. And let's go back to the main page. We're going to go to 0. Let's see, Introduction to Programming Languages. Assembly. Yo, I would like to learn assembly eventually. However, the CPU cannot understand assembly language directly instead. But okay, let's see. I didn't read any of this earlier, and honestly, I should have. I very well should have. I started here, Introduction to C++. The C ended up being so efficient and flexible that they wrote most of Unix to C. Okay. C++ has excellent portability on Unix user. Wait, C, I mean. Okay, what are we adding? It's an extension to C, starting in 1979. Adds, okay. I'm just gonna say this to Mr. Redcon here. We're gonna open up Discord. Okay. To answer your question. Yes, that is my Discord, and it will shortly be changed after this video. Thank you. But yeah, let's see here. Oh, we were doing the notes, right? So, my little notes here, Austin's notes. Okay, you know what? I think we have to quit Discord, just in case. Okay, so functions and statements. So, statement, a type of instruction that causes the program to perform some action, right? And they're functions. So a function is a collection of statements that execute sequentially. I think that's how you spell it. Obviously it's right there, but an object. Okay. Object is a region of storage RAM, I guess, that has a value and other associated we're not even going to do RAM, we're going to do memory. I know I can do the backspace. Memory. Okay, we're just writing it word for word. Usually memory. That has a value and other associated properties. Cool. Okay, we're saving that. Oh. File name to write. Notes.md. So if we go file notes.md, obviously this is just nasty text. Okay. Let's see. How long have we been streaming for? 13 whole minutes. That is not enough. I'm just playing. I would like to learn more, so. Okay, hold up. We gotta go back into the notes. Okay, object, right? And then a variable is, so let's do a little like tab here. Variable is simply named object. A named object, right? And the name of the object, okay. Variable is just a named object. Wait, the name of the object, identifier is the name of the object. So, if a variable is a named object, right? The identifier of the variable, which is an object, right? What? So object is simply a variable, right? So a variable is a region of storage that has a value and other associated properties, right? But it's named. Now if you're wondering what the name of the variable, also known as object, is, it is an identifier. Okay, actually, I'm gonna go back. I'm gonna delete these 2 tabs. Oh, let's do that and just kind of save that. Let me make sure I got that correct. A named object is called a variable, and the name is called an identifier. In general programming, the term object typically refers to a variable, data structure, memory, or function. In C++, the term object has a narrow definition that excludes functions. In order to create a variable, we will use a special kind of declaration statement called a definition. We will clarify the difference between declaration and definition later. Okay, so later when they clarify the difference is when I'll write it. But obviously if we go int x, like define a, do I have like, oh, cancel. Okay, I thought something was messing up. Define a variable named x, comma, type of int. Okay? We have that here. Let me just check my phone real quick. And I did get some texts. Oh no, it appears my cord has been wrapped up in my chair. Oh, freak. That is really wrapped. Okay. Epic. Now that we got that out of the way, we don't even have to worry about my cable getting wrapped up anymore. Okay. So, at compile time, when the compiler sees the statement, it makes a note to itself that we are defining a variable, giving it the name x, and that is a type of integer, or int. More types in a moment. From that point forward, with some limitations that we'll talk about in a future lesson, whenever the compiler sees the identifier x, it will know that we're referencing this variable. Okay, so I guess we can just call x by itself. When the program is run, called runtime, the variable will be instantiated. Instantiation is a fancy word that means the object will be created and assigned a memory address. Variables must be I'm very sorry. Instantiated. Okay. Variables must be instantiated before they can be used to store values. For the sake of the example, let's say the variable x is instantiated at memory location 140. Whenever the program then uses variable x, it will access the value in memory location 140. Instantiated object is also sometimes called an instance. So far, we've covered that variables are named region of storage that can store a data value. How exactly data is stored is a topic for a future lesson. A data type, more commonly just called a type, tells the compiler what kind of value the variable will store. In the above example, our variable x was given. So this is a variable x, right? Was given type int, which means variable x will represent an integer value. An integer is a number that can be written without a fractional component, such as 4, 27, 0, -2, or -12. For short, we can say that x is an integer variable. In C++, the type of variable must be known as compile time. And that type cannot be changed without recompiling the program. This means an integer variable can only hold integer values. I mean, obviously. If you want to store some other kind of value, you need to use a different variable. Integers are just one of many types that C supports out of box. For illustrative purposes, here's another example of defining a variable using data type double width. Well, let's also set one of those. Double, right? Width. Okay, we're using double width. I need to exit this. Okay. 1 moment. I need to. There we have it. I plugged my light in. I only have so much room for my power outlets. So yeah, C++ also allows you to create your own user-defined types. This is something we'll do a lot in future lessons. It's part of what makes C++ so powerful. For these introductory chapters, we'll stick with integer variables because they're conceptually simple, but we'll explore many of the other types. Okay, so we're just going to delete this because, you know, we're sticking with integers. It is possible to define multiple variables in the same type in a single statement by separating the names with a comma. Okay, so int a comma b, or a comma b semicolon is practically the same as int a semicolon int b semicolon, because you're declaring them, I guess. Is that what it's called? Defining them. Yeah, so let's delete this. When defining multiple variables this way, there are two common mistakes that new programmers tend to make. The first mistake is giving each variable a type when defining variables in a sequence. The second mistake is to try to define variables of different types in the same statement. Okay, so I guess yeah, this is just confusing. Obviously, the issue right here is that they defined int twice, right? Because you don't do that. And then here, obviously, they didn't use a semicolon at the end of int before saying double, right? And an int is different from double. Best practice. All the language allows you to do so. Avoid defining multiple variables in a single statement, even though they are the same. Even if they are the same. Hold up. Right here it says this is the same as this. Defining multiple variables this way. So this is obviously correct, but it says avoid defining multiple variables in a single statement, even if they're the same state. Instead, define each variable in a separate statement and then use it. That is actually good advice. So instead of doing int a comma b semicolon, we should do int a, right? And then yada yada yada. If I remember correctly, we have to say what is the reason for this. So obviously I can't just say this is a, because that's obvious. So this does this, int b semicolon, this does that. Okay, you get the deal. Okay, cool. Oh, let's go right here. Okay. Throw back. What is data? Okay. That's like, yeah. What? Where does it say data here? It doesn't, does it? Oh, a data type. So, what's data? That is a sequence of. Okay. What's a value? A value is like a number, like, oh, this integer can have a value of, or this variable can have a value. I'm obviously going to fail. What is a variable? Variable is like, how do you even explain that? It's a variable in the region of memory. Was an identifier. Okay, was a type, enter double, right? Right? So integer, obviously, it's a non-fractional number. 40, I pass. On to the next lesson. In the previous lesson, Introduction to Variables, we covered how to define a variable that we can use to store values. In this lesson, we'll explore how to actually put values into variables and use those values. Also, is my lighting good? Okay, that's decent. As a reminder, here's a short snippet that first allocates a single integer variable named x, then allocates two more integer variables named y and z. Hold on, this is bad practice. Yo, what? We're deleting this. Okay. We're starting from the top here. We're including IOStream, right? We're adding a little enter thing right here. We're adding a little space. And a little space right there. Why does it do this? How do I fix that? Epic. So obviously we need to no. Wait. Okay. What? What if I just broke it? Oh, okay, I have like, okay, I don't have nano anywhere else. Cool. So now, like I said, we're gonna define an integer variable named x. Cool. Now, int y, call it z, semicolon, right? Define two integer variables named y and z. Yeah, we're going to delete that. Cool. Variable assignment. After a variable has been defined, you can give it a value using the equals operator. This process is called copy assignment, or just assignment for short. So obviously, let's add int width, okay? And we have to give it a value of, we can't do width equals like daf, right? Because that's not an integer. We need to give it an integer value. So width here is equivalent to 5, right? So it's copying the value of this into that. Copy assignment, what? Where did I copy assignment of value 5 into variable width? Okay, so this is copying the value of 5 into the integer statement, right? Variable width now has the value of 5. Copy assignment is named such because it copies the value on the right-hand side of the operator instead of variable on the left-hand side of the operator. So this is like, okay, so let's copy this on the right-hand side to this, to width. So now when you type width, it's 5, right? Here's an example where we use assignment twice. Yo, what? Yeah, no, hello. No, we're just gonna do program. CPP. Paste, right? How do you get rid of these ugly spaces? I don't want to see those spaces. I guess it's used for like Python where like spacing is important and you can see, I don't know. We can assign value 7 to variable width. The value 7 that was there is previously, what? I can't even read. There's like a little fly. It can see it. Okay. Let's pay attention here. So apparently we use the, I apologize. Okay. Here's an example where we use assignment twice. Width equals 5 and width equals 7. So now the value, because it's beneath it, right? Because we define it as 5 here and then 7 here, the value changes from 5 to 7. Obviously, we can do 3 and we can do width equals 21, and then the variable width will then have the value of 21, right? One of the most common mistakes that new programmers make is confuse the assignment operator with the equality operator. Assignment is used to assign a value. Equal is used to test whether two operands are equal in value. Yo, what? So let's write a little program. I don't know if I'm wrong, right? Right, okay. Int width. Width is equal to 5, right? Then we can go like this. Int height, right? And then height is also coincidentally equal to 5, right? Now what we can do, obviously, because it says right here, equality operator, right? Can we use height is equal to width? And then just like see what happens? Okay, so obviously, let's actually, you know what, let's remove hello. Let's go to the G++ thing, and then, you know what, we're gonna do program to program, right? No. Program, right? Okay, I did that wrong, didn't I? I'm gonna program to CPP to program. Oh no. Okay. Clearly I'm doing this wrong. Let's just try G++ program. Okay, obviously I big messed up. Huge. What is going on here? I have like 500 lines. Cat program. Hold up, what? Where did those come from? Dude, obviously that's gonna mess up the entire program. Holy moly. Okay, so now let's run A. Nothing happens. Obviously, because I'm getting ahead of myself, I don't know. Okay, let's slow down. Okay. Actually, that's nano again. We're gonna delete this. Okay. Delete this, chief. You betcha. We need to return 0. Why did I delete that? No. Okay, so now that we got this going and rolling. Cool. So, copy and direct initialization. One downside of assignment is that it requires two statements, one to define the variable, one to assign the value. Okay, so initialize what? One downside of assignment, this one, is that it requires two statements, one to define the variable and one to assign the value, right? This is defining the variable and this is assigning the value, right? These two steps can be defined when a variable is defined. Combined when a variable is defined. You can also provide an initial value with a variable at the same time. Int width. So, I am doing this wrong. One downside of assignment is that it requires two statements. One to define the variable. This is obviously defining the variable, and this is assigning the value. Because if this was gone and this just existed, it wouldn't work. Right, because you're not you're not initializing. What is it called? Yeah. C++ supports 3 basic ways to initialize a variable. First, we can do copy initialization by using the equal sign. Epic. So we're gonna do that right now. right now we just have return 0, right? So we gotta fix this. Let's add a little tab right there. Okay. So we can do it integer width. Let's do it the original way, right? We have this, right? So obviously, right here we are, let's see, we're defining the variable, right? After, we have to assign the value of 1 to width, right? Another way we can do this, as it says right here, is in the same one. Int width equals 1. Just like that, right? This is copy initialization. Much like copy assignment, this copies the value on the right-hand side to the variable being created on the left-hand side. So this copies this number into this integer. Second, we can do direct initialization. Okay, so this is copy initialization. Whatever, bro. It's not a spelling bee. This is just initialization. Right? Down here, we can do another one, right? Called direct initialization. Direct initialization. Right? We can add a few spaces, or we can kind of tab here. No, what am I doing? Okay. So direct initialization uses parentheses, right? Int width one. Okay, so what's going on? Let's read. For simple data types like integers, copy and direct initialization are essentially the same. But for some advanced types, direct initialization can perform better than copy initialization. Prior to C++ 11, direct initialization was recommended over copy in most cases because of this performance boost. Right? So if you're running something that needs to be run in a set amount of time, it's better to use direct initialization with parentheses over copy initialization. Okay? So essentially they're the same, but this is Speedy Gonzalez. Okay? Speedy. Brace initialization. Unfortunately, parentheses-based direct initialization can't be used for all types of initialization, such as initializing an object with a list of data. An attempt to provide a more consistent initialization mechanism, C++ 11. Okay, so we gotta remember, we gotta be working with brace initialization here. It's quick, right? It's quick. Brace initialization. And I presume it's probably like the upgrade version of direct, right? Oh, also, okay, so this is called brace or uniform initialization, right? So let's run back over here. So there are two ways to do this. Direct brace initialization of the value 5 into the variable width. Value 5 into width. Or copy brace. Wait, what? So there's direct brace. Okay, so these are essentially these, except with brackets, right? So int width of 5. 5. Right? But I don't like that. Wait. Direct initialization is faster. Remember, it's better if you learn the faster one, right? So we should always do direct initialization instead of copy, right? Or we can do, so this is brace or uniform initialization, but like, it's not. It's uniform direct, right? Or we can do int. Let's see if I can do this without looking. Wait. Okay. Brackets. Like. I was close. You gotta add spaces. And of course the semicolon, right? The semicolon. So this is, I guess, copy direct. Okay. These two forms function, but direct is generally preferred. So remember, learn direct! Initializing a variable with empty braces indicates zero initialization. Zero initialization generally initializes the variable to 0. So it's sort of like saying, hey, this variable is here. It's like a placeholder, I guess. Initializing a variable with empty, yeah, okay. Int 0, 0 initialization to the value 0. Okay. Direct. So I should always use uniform direct. Best. My throat. So, let's see. Where was I? Comes in two forms. Okay. Zero initialization. Okay, let's work with that. Okay. Let's see. Int width. Obviously, this is zero initialization, right? So just like that. No. Like that. Right. And obviously, this is zero initialization. Just means equals 0. Cool. That's gonna bother me for like the rest of the day if I don't copy these. Or caps these. Okay. Brace initialization has added the benefit of disallowing narrowing conversions. This means that if you're trying to use a brace initialization to initialize a variable with a value it cannot safely hold, the compiler will throw a warning or an error. For example, int width is 4.5, error not. Oh, okay, so remember a double is with a decimal, right? Whereas an int is not. So let's save this, right? Let's move program to helpful.cpp, right? Let's remove A out here, and then let's create a new one altogether. So we're gonna nano here. We're gonna get include. What are we including? We're including IO stream, right? IO stream. Is that how I do it? And like that? No. Like that? Like that. Right? Let's just return 0. Let's see if I remember how to do this correctly. Right? This is going to be program.cpp, right? Clear. Nano program CPP. Okay, looks to be correct. Okay, so obviously if we go int width, remember we're not using copy, we're using, what's it called? Brace initialization, and we're using direct, right? 4.5, right? Let's go like that. Obviously, if we run this, let's start to the compiler over here, G++, program, right? Cat helpful. What's the correct answer here? Int main, hashtag include. So I'm doing this way wrong. Hashtag include and int main. Do I need the int main part? Do I need int main? What is, okay, hold on, let's read that. Okay. That's fair. Didn't really understand that, but I understood it well enough. You know what I'm saying? Okay. What's how many minutes are we at? We are at 46 minutes. Um, okay. So obviously this isn't going to work once we get it started, right? Let's delete these spaces. It's bothering me. Right. Okay, obviously it starts the compiler, and it's not going to work. And that the reason for that, if I remember correctly, is because it's int width 4.5. Okay, not all double. Okay, yeah, from double to int. Oh, it even tells us how to do it. So obviously, if we change this to double, it will work because double allows for decimals, right? So now if we do it, oh, freak. We can run A. Obviously, it's not going to do anything. But A out. Cool. So let's remove program. And let's kind of go from there. In the above snippet, we're trying to assign a number, 4.5, as a fractional 0.5 to an integer variable. Exactly. Copy and direct initialization will drop the fractional part, resulting in initialization of value 4 into the variable width. However, with brace initialization, this will cause the compiler to issue an error, which is generally a good thing because losing data is rarely desired. Yes. Conversions that can be done without presidential data loss are allowed. Okay, favor direct brace initialization whenever possible. Okay, that's it, boys. It's over. No, I'm just playing. Let's see. Documents, projects, right? Create folder. No. Look. Create. Let's create like a best practices folder. Create folder. Best practices. Okay. And inside here, we're going to take a little screenshot. Okay. We're doing print screen. Select a region, right? We're taking the best practice here. Why? Is that green, bro? Why did it turn green when I tried to take a screenshot? Okay, we're gonna save this. They're probably wondering, where are you saving it? Well, we're saving it to best practices. So now we can do favor direct initialization. Importante. Thank you. Cool. Now let's keep on reading. Many examples in this tutorial series were written before brace initialization existed, and thus still use copy and direct initialization. We're working on getting these updated. Please forgive our lack of adherence to best practices in this regard. Okay, this is the ultimate test. We have to use brace initialization all the time. C++ provides copy, direct, and brace, and copy assignment. Is there a direct or brace assignment? What? When should I initialize 0 versus nothing? Use an explicit initialization value if you're actually adding that value. Okay, so obviously having an empty one automatically does 0 initialization, right? And obviously we don't want that if we're actually defining 0 as an integer, so we have to define 0. And, best practices, we're going to add a little comment there saying we're using that 0 value, right? Initialize your variables. Initializing your variables upon creation. You may eventually find cases where you want to ignore this advice for a specific reason, and that's okay, as long as the choice is made deliberately. Here, let's read the creators of C++. We're gonna read their little thing here. C++ core guidelines. This might come in handy, boys. Yo, what? So is there like a bookmark bar? Preferences? Bookmark bar? Hello? Home? Where do I find this? Right here. Right? Okay. New folder. C++. Yo, I'm not gonna really name it. We're gonna do C++ core guidelines. Boop. And we're going CPP core guidelines. Right? And that's here. Introduction philosophy. Oh my goodness. Well, I mean, once I'm done with my, stuff over here, we're gonna run back over that. But for now, I have to pay attention. So let's clear this. Initialize your variables. You know what? I think after this little one right here, I might do a little bit more, but after that, I'm gonna stop for tonight. So, initialize your variables. You may eventually find cases where that best practice, initialize your variables. Initializing multiple variables. In the last section, we noticed that it is possible to define multiple variables of the same type in a single statement. We also noted that best practices avoids this syntax altogether. However, since you may encounter other code that uses this style, it's still useful to talk a bit about it. For no other reason than to reinforce other reasons you may be avoiding it. You may initialize multiple variables defined on the same line. Okay. You want to use brace initialization, people. Brace initialization. Brace initialization. You gotta remember, use brace initialization. You know what? I'm gonna remove my notes. I'm sorry, I can't do it. In the top statement, A will be left uninitialized, and the compiler may or may not complain. If that doesn't, this is a wait. What? Okay. Oh, okay. Unfortunately, there's a common pitfall that can occur when the programmer mistakenly tries to initialize both variables by using one initialization statement. So this A isn't initialized, right? And the top statement variable A will be left uninitialized, and the compiler may or may not complain. If it doesn't, this is a great way to have your program intermittently crash and produce sporadic results. We'll talk more about this. You know what? Let's see if the compiler will complain. Oh, shoot. Nano helpful. Okay. Use brace initialization. That's what it's called. Brace initialization. Okay. We're just going back here. Wait, can I like... Okay, that's not a thing. Oh. Okay. Initialization and assignment. What is the difference? If what form of initialization should be using, assuming your compiler is C plus. So brace initialization? Direct brace initialization. What's the difference between initialization and assignment? Well, initialization is, let's see, quiz time. Initialization gives a variable an initial value. Assignment gives a variable a value at some point after. Oh, okay. So if I remember correctly, let's see. Like int a equals 5, right? A equals 5. Okay? This is assignment. Right? We want initialization. And we have to use direct brace initialization. So, without looking, let's see if I can do this correctly. A little quiz time for myself. Int a, not even the equal sign. Let's go. 5, right? Direct brace init or something, right? Right, did I do that correctly? A is 5, right? Did I do that? Where is assignment? Wait, let's go back over here. Brace initialization, direct. So don't include the equal sign, please. There's no point. I mean, there is a point, but we don't know the point yet. I mean, I think. Okay. So let me see if I did this correctly. Integer a is equal to 5, right? That's different from assignment. Where's assignment? Assignment is just equals. Used to assign a value to a variable. Okay. 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 You know what? This is about to get complicated. I'm already in the mood to just run through this. So I'm going to take a little break. Like, is there like a stream? Do I even have a stream overlay? Let's see. Can I like, let's search for stream overlay. Like BRB. Okay. You know what? We're gonna, what? No, this is about to be copyright. Oh wait, free downloads. Free downloads? Where's the free download? Free Twitch? No, I just... Okay, I know how to do this. Actually, you know what? I'm not even gonna... I really want to keep learning. So I'm gonna take like a 12-second break. More like a 5-minute break. I'll be right back. Hello? Okay, we're back. It's come to my attention, unfortunately, that the description of this episode is the same as the last one. So we'll be changing that. But later, obviously, because right now we got more important things on our hands, we are in the midst of the introduction to C++, and we have to continue onward. We have to forward. In this lesson, we'll talk more about std, count. I don't even know what that means, which we use in our program Hello World to output the text Hello World to the console. And we'll also explore how to get input from the user, which we use to make our programs more interactive. The IOStream library is part of the C++ standard library that deals with basic input and output. That's what we're using. IOStream. IOStream, right? Input, output, stream. Okay? We use the functionality in this library to get input from the keyboard and output data to the console. The IO part of the IOStream stands for input and output. Why you gotta steal my glory like that, bro? To use the functionality defined within the IOStream library, we need to include the IOStream header at the top of any code file that uses content defined in IOStream, like so. Also, let me just make sure my mute button works. Okay, cool, it's working. This lighting is terrible, so I'm gonna fix that. The lighting is instantly worse, but it's okay. You know what? It's okay. It's a work in progress, boys and girls, ladies and gentlemen, and I will get it fixed. But obviously, IOStream library is input-output stream. std count. The IOStream library contains a few predefined variables for us to use. One of the most useful is std count, which allows us to send data to the console to be printed as text. Count stands for character output. Okay, as a reminder, here's our hello world program. Okay, let's sort of copy and paste this, right? Okay, let's do hello world.cpp. Let's kind of paste this. Why is it's still, oh, it's pasting the numbers. That's crazy, bro. I can't believe you'd do that to me. Okay. So obviously, let's go back into now. I don't know why I exited. This program, we have included input-output stream, so we have access to std count. Inside our main function, we use std count, which, let's see, character output, yeah? Okay. Along with the insertion operator to send the text hello world to the console to be printed. Oh, that's dope. So it's kind of like if we're going to echo hi, we can put it in output.text, right? So that way if we cat output.text, it's going to say hi, right? So we can remove output.text and clear. It's pretty much doing the insertion operator to send the text hello world to the console to be printed. That is crazy. std character output can only print text. It can also print, it cannot only print text, it can also print numbers. So let's go over here and actually let's write a little new thing. So practice.cpp, right? Let's see, hashtag include, I'm just trying not to look, bro. IOStream, right? And then we obviously need to, I'm missing something. Okay, int name. I'm always going to forget that. And then like brackets like that. We can do return 0. Semicolon. It's going to go above here. And what are we doing? So, std count. Character output, right? We're going to do 5. Wait, we have to add a semicolon at the end of it, right? Okay. Obviously, as we learned at the very, very beginning, we can go like this to have a new line, right? So 5. New line. I don't know why I'm doing this, but you know what? We're working with it, okay? Like, bear with me. 5. Okay, new line. So obviously, if I didn't do the new, line there, it would be on the same line, which just looks nasty. It looks disgusting. It's absolutely barbaric. Right. See, this is what happens when you leave stuff on the same line. Don't do that. Okay, prints for the console, right? It can also print numbers. That's where we're at. It can also print the value of variables. Okay, screw it. We're going back to practice over here. Yes, I know. There's like one down here. Like, what are you doing? No, I'm doing what I want to. So int main, right? We gotta get that little space going, just because that's cute and everything. We gotta get the tabs out, right? I didn't tab return 0. I tabbed it semicolon. It's like genius level IQ. Okay. So, it can also be used to print the value of variables. Hold up. Actually, let's keep return 0 just because I need it. So obviously, we're using a direct brace initialization. Int x is going to be 5, right? Semicolon. Initialize with the value of 5. You know what? We'll just kind of copy this part right here. Okay? So, like this said, count is used for character output, right? And then we're doing x here. Print value of x. Because what it's doing is it's taking the insertion operator to send the text hello world to the console. So it's taking the value of 5. See, int x is 5. Right? Because we're initializing, or whatever it's called, defining the variable in the same statement that we declared it in, or whatever, or the same line, right? Int, okay, we create x, and then we defined it as 5. We gave it the value of 5, right? Then it's taking the character output of x and printing it to the terminal. Print value of 5 to console. Do it. We're gonna run this, obviously, a out. Okay. So, this produces the result 5. To print more than one thing on the same line, the insertion operator can be used multiple times in a single statement to concatenate on. Clearly, I also need to work on my English, so concatenate. That's where we're at. Concatenate. To print more than one thing on the same line, the insertion operator can be used multiple times in a single statement to concatenate. Link together multiple pieces of output. Okay, I'm gonna exit this just because it's bothering me. We're gonna do Control W here. We're gonna clear again. Okay. Nano practice. I think that's what we're using, right? So obviously, we're gonna take the character. Is that what's called? The character output. So counts, right? And then hello. Okay, and obviously it's telling us to use this multiple times for practice. Just a little example here. If we don't include the space, and we were to like this, and then run. Dude, is this not? Okay, A. Right? Hello world, no space, right? As I was trying to say. So you need to add this space right here. Right? And this is also the same as, you know what, let's just go new line here. This is practically the same as the character output of, we're going to output this to the console, right? The string hello world. Obviously, it's not going to be the same because this is lowercase. So we're going to uppercase this. And we're going to run. Oh, I forgot to add a semicolon, didn't I? Look at me. I'm already learning what the errors mean. Yeah, the error was simple. Okay. Okay, A out. And obviously, they are exactly the same. Right? We can concatenate multiple pieces of output. This program prints hello world. Here's another example where you print both text and the value of a variable in the same statement. Cool, so we're gonna nano practice C++ here. I can go like that, right? We need to use, what's it called? Direct brace initialization. So int x, obviously we need to have that as 5. Okay, semicolon at the end of this line. Dude, I am so bad at semicolons. Okay, so now we're gonna take character output count, and we're gonna do the string x is equal to, oh my fudge, I cannot do this. And then, oh, okay, so here what we're doing is x is 5, right? We're doing the string x is equal to, and we're sending that to the console, and then we're sending the actual value of 5 to the console. And this program prints x is equal to 5. Oh, no, no, no. No! Okay, yo it. We can't be having that right here. So, no. Alright, in practice. What other stuff is in here? Hello world. Obviously, we're going to delete. You know what? We're going to delete all of everything besides A. Okay, thank you. Now we're going to nano practice.cpp. We're going to paste this. We're going to remove the number. Oh, there were no numbers this time. That's crazy, dude. Save. And now we're going to run it. So G++, practice C++, A, x is equal to 5. Obviously, if we were actually doing that, I would add a new line here just because that bothers me so much. Okay. I did not do that correctly. Obviously, it's going to get more complicated from here on out. Oh, shoot. We still need to do this. Okay. Nano practice. I'm just trying to make this work. I'm forgetting semicolons. Okay, G++, practice, A out. X is equal to 5, new line. Okay, we did that correctly. What would you expect this program to print? Okay, let's see. Hi, my name is Alex. What? Well, obviously I'm not surprised at the result. They didn't add a space. I don't expect it to be like a new line or anything. Separate output statements don't result in separate lines of output on the console. Well, we already figured that out because we're super geniuses. If we want to print separate lines of output to the console, we need to tell the console when to move the cursor onto the next line. One way to do that is std end line. When output with character output end line prints a new line character to the console, causing the cursor to go to the start of the next line. In this context, end line stands for end line. Okay. So, can't you just print the new line thing that we learned at the very, very beginning? Oh. Okay. Well, obviously we're going to learn the difference here. Standard end line versus new line. Using standard inline can be a bit inefficient. It actually does two jobs. It moves the cursor to the next line and it flushes the output. Make sure that it shows up on the screen immediately. When writing text to the console using character output usually flushes the output away. And if it doesn't, it usually doesn't matter. So having a standard inline flush is really important. Because of this, use the is typically preferred instead. The new line character, this is regex, right? Or something? Isn't that what it is? Regex? Right? No, that's... Bro. I'm familiar with regex, boys. Okay, moves the cursor to the next line. But doesn't do the redundant flush, so it performs right. The new line character also tends to be easier to read, since it's both shorter and can be embedded into existing text. So obviously, instead of doing all this stuff, okay, let's find the output here. I promise I didn't cheat. Okay, into main, into x is 5, right? Character output x is equal to, and then 5, and then new line, right? So x is equal to, semicolon, and then we're doing 5, right? This is what we did earlier, by the way. That's what I did on my own. Yep. Now standard character output, maybe STD stands for, STD stands for C++. Is it just like standard? Okay, thank God. I've been calling it STD. So we now know to call it standard. Yeah, no one wants to say STD character output. But yeah, and that's all, folks, obviously, with the new line at the end, which isn't necessary, but in some instances it is. For example, if I weren't going to include the new line at the end here, it would go like right here, like this, right? Just like that. And obviously we want it on a new line. So, note when using new line, is used to move the cursor on the next line. Okay, maybe it's next line instead of new line, right? Single quotes are needed. When embedded into text that's already double quoted, the single quotes aren't needed. We'll cover what is in more detail when we go into the lesson on characters. Dude, what am I at right now? We're 1.5. Oh, Lord. Best practice. Okay, remember, boys, we're taking a screenshot. You see how this is green and this is red? Why isn't it like that normally? My monitor is probably tweaking. We're going to save to the best practices folder. Import. Okay, I'll rename these later. Importante. Okay. Standard sen is another variable that is defined in the IOStream library, where standard character output prints data to the console using the insertion operator. Character input reads input from a keyboard using the extraction operator. No way. Okay, I'm gonna spend a minute. And how long is this? I'm obviously gonna fail this quiz, by the way, but iron practice. Actually, don't iron practice. Nano practice, right? We're using only best methods here. Okay. Let's add a little space just because I like that. Let's tab this. Okay, so standard character output. Okay, standard character input. Standard character output. Okay, so let's try making this by yourself. Enter a number. You entered 4, right? Let's try that. Enter a number. You entered 4. Okay, we gotta think for a bit here. So standard character output, we're gonna do okay, enter a number. And actually we're gonna do it like that. Okay, standard, I don't even know if I'm doing this correctly. Yo, I am not doing this correctly. Enter a number. Okay, standard character output, enter a number. Okay, think. I really want to do this by myself, but it's obviously very complicated. Standard character output, enter a number. Int x. Nope. Yep. How do you even do this? Where did I put it? Oh, it's over here. Insert a number into x and leave it as 0. And then put character input into x. And then that way you could... Okay, that's fair. So obviously, best practices, am I right? Oh, I also forgot to include the semicolon up here. But that doesn't matter. Also, let me actually just check something real quick. Hey, cool. I wasn't checking how to do it. Okay. Now standard character inputs, right? How's this going? You know what? We want to input whatever into x and like that. How does it work? Okay, obviously I'm not. Oh, I forgot to reverse it. I did it earlier correctly. And then standard count, you entered x, new line. Okay, so let's try this. It's better if we, do it ourselves and then try to re-familiarize ourselves with it. Standard character outputs. Wait, we're gonna go this way. You entered space, right? Comma. No. Let's just do a new line. Dash n. Yes, practice C++. G. And you compiler practice, please. Did I forget? Dude. I will get there, people. I will get there. Practice. What? A. We are getting there. Character input, character output, mastered. No, I'm just playing. But we'll get there eventually. Okay, so obviously we just did that ourselves. It's an easy way to get keyboard input from a user. Okay, best practice. You know what? There's some debate over whether it's necessary to initialize a variable immediately before you give it to a user, provide value via another source. So you do it in a new line because okay. For advanced readers, the C++ input-output library does not provide a way to accept keyboard input without having the user press enter. This is something you desire. So we always have to hit enter, right? Mind blown. New programmers often mix up character input, character output, the insertion operator, and the extraction operator. Here's an easy way to remember. Standard character input and standard character output always go left-hand side of the statement. Standard character output is used for output value. Standard character input is used for input. Obviously, this is used with standard output. It shows the direction that the data is moving. It's moving out, right? This is moving in, right? Bada bing, bada boom, bam. Quiz time. Consider the following program that we used above. This program expects you to enter an integer value. Okay. As the variable x that the user input will no longer be put into as an integer variable. Run this program multiple times to describe what happens when you enter the following types of input instead. A. Such a letter such as H. Okay, so it actually wants us to do that. Or just in our heads. I don't think H would work, right? Because it's not an integer, right? Therefore, X is 0. Okay. So, standard character output, enter a number. So we enter 4. Okay, enter H. A number with a fractional component, that's a double, so it would be... What's... Is this... Okay. A small negative integer such as -3, this works fine because it's an integer. Words such as hello, 0. Okay. Really big number. Maybe it's out of bounds. A seemingly random number.